In this video, I will explain you how to derive an expression that is lens maker's formula. Now, a lens has two surfaces basically. One is a surface like this and another one is a surface like this. Now, this is a rarer medium, okay, say for example air. Now, this is a denser medium, for example glass. Now, from rarer medium, light ray would enter into a denser medium, then again at surface 2, next surface it is, from at here it would enter back to rarer medium number 1. So there are two surfaces here and two mediums here. Okay, so what will happen in this case, in the case of lens? Previously I have explained you the refraction occurring at a curved surface, and the equation was this: when the light enters from rarer to denser medium, that is, if you don't have a surface here, instead of that, if you are having fully this side made up of with a material of refractive index, this one, that is nothing but refractive index of denser medium. So this is the example, a curved surface in this way. We had the object here and it was creating an image here, and this was the equation for that. Now in the second case, that is light entering from denser to rarer medium, that is a case like this. We kept our object here and we have seen the image is forming at the same place itself, on the same side itself. So whatever may be the position of image, we got to know that the equation for this refraction is this one. So here the first case, rarer to denser, and from here I kept an object and we have seen an image here. Now in the second case, that is from denser to rarer, this is the equation. I kept my object here and we have seen the image here itself. So on combining these two, so this surface and this surface, like I am cutting this surface in this way and cutting this surface in this way. So this part when joined with this part, so these two shaded region when joined, I will have a lens in this way. So both the equation I have to apply here. So we will start from object. So one ray is going in this direction. So this is the best picture that explains the double refraction. So I kept my object here. At P I kept my object, and from object one ray is going in this direction, and which is along the normal to the both the surface. So at this surface this is the normal, and at the surface this is the normal. So this ray will go undeviated, because with normal the angle made at both the surface it is 0, so undeviated. One ray in this way. And one next ray, this is the incident ray. Now from rarer to denser it is. Now this is the incident angle. Now this is my refracted angle. So refracted angle would be less than incident angle when it is entering from rarer to denser, because this refracted ray will bend towards the normal. So this ray was supposed to move in this direction, but the problem is this refracted ray when reached this surface, see at this surface, now the ray is entering. Okay, this is the ray, and with this surface will have its normal, and this is my incident angle. But we know that here it is light entering from denser to rarer. So refraction will occur even at this surface, and this would be the angle of refraction. So denser to rarer, we know that after refraction the refracted ray would move away from the normal. So this is my normal and this is my refracted ray. So this was supposed to travel in this way, but this has bent in this direction and gone here. So one refraction here, and with this refraction it was supposed to create an image here, but what has happened, this ray when it was entering from this denser medium to rarer medium, it has again bent in this direction and created an image here. So actually this ray was supposed to create an image here with this surface, but what this surface has done, this has created an actual image at here. So one refraction it was supposed to go in this way, but this ray when reached here, again one more refraction occurred and that has now bent in this way. So I can say that this created image here, okay, this created an image here. Now this is the ray that was supposed to create an image here. Now this will act as an incident ray for the second surface and will create an image here. Or I can say that the whole scenario I will split into two. That is entering from rarer to denser medium, that is in this way, rarer to denser medium, and my object is here. This object will create an image here, that is at I1. This is one of my case, and the next case I have my curved surface in this way. This image which is created by the surface 1 will act as object for the second surface. So this is my surface 1, this surface. Now for second surface, this image that the I1 would act as, this image I1 act as an object for the second surface and that would create. So this is I1. So this would act as my object for second surface and will create an image here, I. What has happened? This has created an image here. One surface S1, the S1 has created an image at I1. Now this image will act as an object for second surface and will create an image here. So if that concept is clear, then the whole process would be super easy with you. Okay. So we already have derived equations, that is from rarer to denser this one. Now from denser to rarer this equation. From this equation I can easily obtain this equation by simply replacing mu2 with mu1 and mu1 with mu2. Okay. Now we will substitute the values. Okay, so this is P, yeah, this is O and I and I1. Okay, yeah, P, O, I and I1. Now at surface S1, this is my surface S1 and this is my surface S2. Light enters from rarer to denser. So I have to use this equation. What is that equation? Mu2 by V minus mu1 divided by U is equal to mu2 minus mu1 divided by R. This we already have learned. Now we will substitute the values for V and U. We know object distance is PO. Here I kept my object, right? PO, but that length I am going to take in leftward direction, so that would be negative. So this implies that mu2 divided by V is my image distance. Okay, so this is my image. So surface 1 will create an image here, OI, and that is measured in rightward direction. Okay, OI is measured in rightward direction, so that is plus OI. Plus OI, because it is measured in rightward direction, image distance. This minus U1 divided by now object distance, U. What is U? OP. What is OP? OP is measured in leftward direction, so divided by minus OP is equal to mu2 divided by mu1 divided by mu2 minus mu1 divided by R. So this surface will have a R here, R1 here. So that is measured in rightward direction. So this surface will have a radius here, that is measured in rightward direction. So plus R1. Now at surface 2, S2 here. Okay, S2, light enters from denser to rarer medium. So I have to apply this equation. Okay, what is that equation? Mu1 by, just substitute interchange mu2 with mu1. So mu1 divided by V minus mu2 divided by U is equal to mu1 minus mu2 divided by R. This implies, what is V here? my final image is formed here. This is my object for second surface. My final image is here, measured in rightward direction itself. Okay, so that would be plus OI. Okay, so mu1 divided by plus OI plus minus mu2 divided by what is image distance, object distance. My object is here itself, and that is also measured in rightward direction, so that is plus OI1, okay, is equal to mu1 minus mu2 divided by R would be, okay, for this surface, second surface, my radius will come here, R2. So this is R2 and this one is R1. So this one is R1 and here it is R2. Between center to C2, between C2 to O it is R2, between O to C1 it is R1. Okay, so this one is R1 and this one is R2. For the second surface, radius will come here and that is measured in leftward direction. Okay, so this would be minus R2. So just rearrange this equation. This says that this implies mu2 divided by OI minus of minus plus mu1 divided by OP is equal to, okay, now it is not OI1 here, okay, OI1. Okay, here my image is formed at OI1, right? First surface is making an image at OI1. So it is OI1 is equal to mu2 minus mu1 divided by R plus R1. So this implies that mu1 divided by OI minus mu2 divided by OI1 is equal to mu2 minus mu1 divided by, okay, this would be mu1, okay, minus multiplied by the whole thing would be mu2 minus mu1 divided by R2. Okay, now I'm rubbing this part. So I have now my final equation 1 and I have my second final equation 2. So on adding 1 with 2, see, mu2 by OI1 plus mu2 divided by OI1 minus mu2 divided by OI1. These two will cancel. So the remaining terms I have to add mu1 divided by OI plus mu1 divided by OP is equal to mu2 minus mu1 is a common term into 1 by R1 plus 1 by R2. Yes, plus 1 by R2. Okay, now mu1 divided by OI. What is actually OI? This is my actual image distance, right? So mu1 divided by OI is my image distance and that is measured in rightward direction. So plus V plus mu1 divided by OP. OP is my object distance and measured in leftward. So that's the reason it is minus U is equal to mu2 minus mu1 into 1 by R1. R1 is measured in rightward direction between O and C1. So that is 1 by R1 plus itself. Now R2 is measured in leftward direction. So that would be 1 by minus plus 1 by minus R2. So on rearranging, this would be mu1 divided by V minus plus, okay, minus mu1 divided by U is equal to mu2 minus mu1 into 1 by R1 minus 1 by R2. So here I have applied sign and substituted the value. Now I can take mu in common. So mu1 into 1 by V minus 1 by U is equal to mu2 minus, mu2 minus mu1 into 1 by R1 minus 1 by R2. Okay, now, we have learned previously that 1 by v minus 1 by u, in the case of length it is 1 by f. So mu 1 into 1 by f is equal to mu 2 minus mu 1 into 1 by r1 minus 1 by r2. And we also have learned 1 by focal length is equal to power, and power is nothing but measured in diopter. So 1 by f can be written as mu 1 into power of the lens is equal to mu 2 minus mu 1 into 1 by r1 minus 1 by r2. So these are the two standard equations used by lens makers. So the first equation is known as lens maker's equation. These two are lens makers. I have just substituted the value of 1 by f as p, power. Now if you may ask, if both the surfaces are made with the same radius, this one is same and this one is same, which means r1 and r2 is same, then this term would be 0 and the whole term will become 0, right? No, because if both of them are same, then in that case, see, this one is r1, right? So r1 would be measured in rightward direction and this thing is r2 is measured in leftward direction. So r1 will become positive and r2 will become negative. So this negative plus negative into negative will become positive. So don't worry about this structure of the equation. Whenever you are substituting the values with proper magnitude and sign, then there won't be any problem with this equation. Okay, so this is lens maker's formula. This is very simple to derive. You just need to consider this as S1 and S2 and have to substitute, give the proper equations, that is light entering from rarer medium to denser medium, then denser to rarer medium, and first when rarer to denser light is entering, it is creating an image at one place, and that image is going to act as, so this image is going to act as object for this surface, and that is going to create an image here. So just write down two equations for these two scenarios, that is this create an image I1 here. For that you write down an equation. Now this image of the previous case act as an object and that create a new image here, that is for surface 2, and write down its own equation, then add them, you will get this equation. So mu1 into 1 by f is equal to mu 2 minus mu 1 into 1 by r minus 1 by r1 minus 1 by r2. Just take mu 1 to that side, so that would be 1 by f is equal to mu 1. So mu 2 divided by mu 1 minus mu 1 divided by mu 1 into 1 by r1 minus 1 by r2. So mu 2 divided by mu 1 is nothing but mu 2 1. So this implies mu 2 1 minus mu 1 by mu 1 would be 1 itself, okay, into 1 by r1 minus 1 by r2. This can be another equation for 1 by f, or this can be another equation for focal length, that is mu 2 1 minus 1 into 1 by r1 minus 1 by r2. So just do small substitutions, you will get all these equations, this one and this one. Okay, this is all about lens maker's formula. Okay, thank you.